All right, good afternoon. Happy Wednesday. Seems like a long day because of all the classes. But anyhow, don't forget that lesson 3.2 is due tonight. Lesson review 3.2 test is due on Thursday, and we're going to have an exam on 3.2 on Friday at 8 a.m. All right. The solving by completing the square and the quadratic formula, that's due on Monday night. And if I can get to it today, I'm going to try to teach lesson 3.3. Okay, couple of announcements. I think I mentioned this the other day, but I'm just going to mention it again. In 3.2, the 3.2 exam, in that review 3.2 with my answers, I was a little more in depth than what they're asking for. So I just want to make sure if you've already practiced 3.2 online, you're already aware of this. So they're asking you to identify the real part, the imaginary part, and what set a number belongs. So if you have 7 plus I, the real part would be 7, the imaginary part would be 1. I is the imaginary unit. So this number would be classified as a complex number. If you have something like -6, the real part would be -6, the imaginary part would be 0. And this would be classified as a complex real. If you have something like 10i, the real part would be 0, the imaginary part would be 10, and this would be classified as a complex imaginary. I classified it as a complex pure imaginary, but regardless, they're classifying this as complex real, complex imaginary in this book. So you will notice that if you do the online problems, obviously, and I'm hoping you're noticing that doing the online problems is beneficial because basically you're finding out exactly what the test looks like. The last thing I want to just say is don't be afraid to talk to me. You know, I am sending out quarter grades on Friday. And, you know, this is my feeling. If you want an A and you have a B, talk to me. You know, we can take a look at things and see what's going on and see what we can do. You know, it doesn't make any sense that, let's say you failed a test or 2 tests, you know, that now you're going to fail the class. You're never going to get that A. No, there's always, nothing's ever too late except when you're dead. You know, when you're dead, it's over. So until then, other things can be fixed. Most things can be fixed. And so, but you have to talk to me. If you don't talk to me, I think you just basically don't care, you know, what your grade is. But by talking to me, I'm going to say one of 2 things, yes or no, or let's do this to go forward. Just remember the bottom line, I'm on your side. So I'm on your side, even though some of you think I'm not, I am on your side. I want you to get whatever grade you want in this class, and I'm going to help you to get whatever grade you want, but you have to speak to me. You have to develop a relationship with me as a student teacher, you know, and we work together, you know, just like you do in your teams. All right, so before we get started, I just want to focus on 3.2. Anybody have any questions about 3.2? You should also know how to do the electric circuit. So, questions about 3.2? All right, let's skip over to solving quadratics by completing the square, the quadratic formula. I am going to work some more problems like that in class, but these are out of your book and they're more difficult. So that's why I gave you these practice so you could get up to speed on this before you get the more difficult problems. Okay, anybody want me to work any of these problems? Anybody have any questions? All right, are you guys there? Can you hear me?
Yes.
Yeah. All right. So let's look at lesson 3.3. And in this lesson, we're going to find complex solutions to quadratics. So up to this point, we've used different methods to solve quadratic equations, but we've only come up with real solutions. So now we're going to come up with imaginary solutions. So the standard for this is California Common Core Standard N-CN.7. And I want to take a look at the Explorer first of all. So in the Explorer, you're investigating graphs. So what they do is they give you a quadratic that looks like this. So that's not the parent, but that's just the graph that they give you. And they start doing things to this graph. So the first one, they're going to take 2x squared plus 4x and add a 1. So to make that look like that, we're going to subtract 1. The next problem, they take 2x squared plus 4x plus 2 and set it equal to 0. And if you subtract 2, you get 2x squared plus 4x equals a negative 2. And in the next one, they take 2x squared plus 4x plus 3, set it equal to 0, and subtract 3 would be 2x squared plus 4x equals negative 3. All right, now, so basically what they're doing is we're going to use a graphical approach to talk about the solutions. So under y sub 1 in the calculator, you're going to put 2x squared plus 4x, and that's actually going to be your y sub 1 all the way down. So your y sub 1 is going to stay the same. For this problem, y sub 2 is going to be a horizontal line through negative 1. Y sub 2 on this problem is going to be y equals negative 2, which is a horizontal line through y equals negative 2. And y sub 2 on this one is going to be negative 3, which is a horizontal line going through negative 3. So basically, they want to know about the solutions. So when you graph this, you're going to get the parabola, that's y sub 1, and you're going to have these different lines. So if you graph these all at once, this is what this is going to look like. This right here is for y equals negative 1, and that shows 2 real solutions because it's intersecting the graph twice. Now, we don't know what the solutions are. We don't care. We just know that there are going to be 2 real solutions. The next graph is the one that's y equals negative 2. And you notice that's crossing the graph one time. So that means there's 1 real solution. And finally, this is y equals negative 3, and it's missing the graph completely, which means there's no real solutions. Now, they're going to say this a bunch of different ways. They could say no real solutions. They could say 2 non-real solutions. They could say 2 imaginary solutions. But regardless, it's no real solutions. Okay, so I kind of want to just show you the Explorer. They're going to give you a function and do some things in the function. They want you to look at it graphically. Either 2 solutions, 1 solution, or no real solutions. Okay, the second part of this lesson is solving by completing the square. And I want to work one or two of the problems that they have in the book here, which are a little more complicated than the ones that I gave you on the review. So we're going to solve the quadratic by completing the square. I'm actually on page 141. So we have 3x squared plus 9x minus 6 equals 0. And you want to notice that we don't want to try to complete the square with that. And this is actually, we can simplify and just get rid of it. So divide by 3, divide by 3, divide by 3, divide by 3. And so now, given the choice, we want to factor it, but we have to solve by completing the square. So we're going to banish that -2 by adding 2 to both sides. And we're going to take half of 3. Do not change it to a decimal. So half of 3 would be 3 halves. And when you square it, you get 9/4. So this is the number you're going to add to both sides. And this is the number that you're going to create the square from, which would be x plus 3 halves. So on the right side, you need a common denominator. So you're going to multiply by 4 over 4. And you get 8/4 plus 9/4 is 17/4. And this is x plus 3 halves, quantity squared. So now we take the square root of both sides. Make sure you bring the radical all the way down. So you're going to get plus or minus x plus 3 halves comes out, and we have to split up the radical because you cannot have a fraction under a radical. So what we get here is x plus 3 halves is equal to plus or minus square root of 17 over 2. So when you subtract this, you get -3 halves plus or minus the square root of 17 over 2. So those are your two solutions, -3 plus or minus square root of 17 all over 2, because you have to add the fractions. So this answer would be -3 minus square root of 17 over 2. And this would be -3 plus square root of 17 over 2. And let me just tell you, when I see those radicals, that means we couldn't factor this. And you should know that all radicals and all imaginaries come in pairs. So let's make a note of that. So all radicals and all complex numbers, I'm just going to call them imaginaries, all imaginaries imaginary solutions come in pairs. So make sure you give me exact answers. Make sure that you simplify the radicals. Make sure you get common denominators when you're adding or subtracting. Make sure you get common denominators when you're adding in anything. So this problem's a little more difficult than some of the ones you've had. Okay, any questions about this one? The next problem I'm going to do is going to have an imaginary in it. So nothing is really new right now. We're just putting it all together. So everything we've been preparing for is showing up now in these problems. Okay. So the next problem I'm also going to solve by completing the square. And this problem is x squared minus 2x plus 7 equals 0. So remember that with this, if you do not have a perfect square trinomial, move the constant by subtracting 7 to both sides. So now I noticed that some of the groups were messing this up. Remember, you're taking half a -2, which is a -1. And so some of the groups were not putting a negative, and that's going to cause you to get wrong answers. So this is the one that you're adding to both sides. This negative is what goes in here. So some of the groups are writing x plus 1. Pay attention to what you're doing. Just write this over and you can follow it. Add 1 to both sides. The -1 goes there in the binomial square. So this is -6. So when you take the square root of both sides, you're going to get a negative under a radical. So that means that you have to bring out, that's square root of -1, so you have to bring out an I. Remember, I told you that in calculus, they're going to be writing the I in front. We're not going to do that because I want it written in the form A plus BI by completing the square. Okay, can I erase this? Okay. All right. Well, the next thing is solving using the quadratic formula. So I'll work one more problem with solving using the quadratic formula. Okay, what do you think of, what do you like, or what do you notice about this problem?
The first
all negative.
All the negatives. And if you look at the book on page 143, they left all the negatives in there. I'm not leaving all the negatives in there. So I'm multiplying everything through by a negative. I don't want my A to be negative. I don't want my B to be negative, and I don't want my C to be negative. But they left it in there for some reason. I don't know. There's a lot of weird things in the book. Yeah, sometimes just look at my notes. So multiply by a -1, multiply by a -1, multiply by a -1, and multiply by a -1 is 0. So your A, B's, and C's are positive. And you were probably singing this song all day yesterday. X is equal to -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So notice how my problem looks much nicer than theirs. And not only that, but they're going to end up with a negative in the denominator. We're not going to end up with a negative in the denominator. And they're being inconsistent because they left the negative in the denominator. So this is -2 plus or minus the square root of 4, and a negative times a positive is a negative, and that's 20 times 8 is 160. It's imaginary. So this would be -2 plus or minus the square root of, isn't that -156? So it's going to be -2 plus or minus the square root of something I, because there's a negative under the radical, all divided by 10. And now we have to do a prime factorization on 156. So we can take out a 2 times 7 is 14 with one remainder. 2 times what is 16? 8. Take out a 2 times 3 is 6 with one remainder. 2 times 9 is 18. Take out a 3 would be 13. So over here we have 2 times 2 times 3 times 13. So who gets to come out? 2 gets to come out, and a 39 gets stuck, I, all divided by 10. So divide by 2. Divide by 2 is 1. And divide by 2 is 5. Now, here's the deal. I forgot to tell period 3 this, but you have to write all imaginaries in the form a plus bi. Now, you're going to have to see what they're doing in the evaluate, but if you were with me on a test, you would have to write it as the real part plus or minus the imaginary part. Don't circle that. We got to put it in a solution set. So you would have to write it in the form a plus bi when you have imaginaries. So your two solutions would be negative 1/5 minus square root of 39 over 5i and negative 1/5 plus square root of 39 over 5i. So standard form of a complex number. And notice the imaginaries came in pairs. Any questions? Yeah, we'll see how these problems in your book are a little more difficult. That's why I wanted to do those practice sheets with you, so you get up to speed on this, because they just jumped right in to some good problems. All right. All right, the next thing I want to talk about is the discriminant. And the discriminant is what's underneath the radical of the quadratic formula. So b squared minus 4ac, when it's greater than 0 or positive, it means that there's two real solutions. When the discriminant is equal to 0, it means there's one real solution. And when the discriminant is negative or less than 0, there's no real solutions, which means there's two imaginaries or two non-real solutions. Now, what's the purpose of this? Well, the discriminant does not tell you what the solutions are, but it tells you the nature of the solutions. So for example, let's say we have a real life problem to do with a quadratic. Do you want to go through all those solving methods? Or would you rather look at the discriminant and find out there's no real solutions? In a real life problem, if there's no real solutions, why do the problem? So I'm going to show you the value of this in a minute, but for now, let's find the discriminant and state the nature of the roots. So let's say you have 9x squared minus 2x minus 1 equals 0. Well, that's in standard form, and we could get the ABC, and we want to look at the discriminant because they're asking us about the solutions. Are the solutions real or are they imaginary? What's going on here? So what's going on with the solutions? Well, B is -2. So that would be -2 quantity squared minus 4 times 9 times -1. Wait a minute, we don't set that equal to 0. It's just a discriminant. So this would be a +4, and a negative times a negative is a 36. So this would be plus 36, which is 40. So what that tells you, it doesn't tell you what the solutions are, but because it's positive, it means there's 2 real solutions.
Can you move it down a bit, Ms. Birch? Thank you.
Okay, let's take a look at another one, the discriminant. Well, first of all, you can't tell what A, B, and C are because that's 7 over there. You have to set it equal to 0 and put it in standard form. So this would be x squared minus 3x and subtract 7 from both sides would be that. So when you look at the discriminant, we get -3 quantity squared minus 4 times 1 times -7. For the fun of it, I'm going to make this negative. So now your A would be -1. So this would be a +9, and a negative times a negative times a negative is a -28. So this would be a -19. So this means that there's no real solutions. Well, if this was a real life problem, wouldn't this be nice to look at the discriminant and say, we're not going to even do the problem. It's impossible. It's impossible to do the problem. There's no real solutions. All right, so that's the discriminant. It's really easy. You just take the b squared minus 4ac, make sure you put the b in parentheses, and the 4ac is a product. And does anybody have any questions about the discriminant? Okay, like I said, the discriminant does not tell you what the solutions are, but it is useful in seeing what type of solutions you would get if you did solve it. And like I said, for real life problems like we're going to look at, it's going to be beneficial to look at the discriminant, because why do the problem if it doesn't work? If there's no solutions, no real solution. All right, so look on page 142A. Okay, read with me. A ball is thrown in the air with initial velocity of 14 meters per second from an initial height of 2 meters. So the ball's being thrown up in the air and coming down. So that's a parabolic shape. So we're expecting a quadratic with a negative in front. So it says a ball is thrown in the air with initial velocity of 14 meters per second from an initial height of 2 meters. The ball's height in meters at time t in seconds can be modeled by this quadratic. So this problem is being modeled by this. There it is. So there's your negative, there's your upside down parabola, plus 14t plus 2. So this problem is modeled by this quadratic function of height in terms of time. So here's what they ask. Does the ball reach a height of 12 meters? Well, if this quadratic models this problem, doesn't it mean if we get a solution that it's possible for the ball to reach 12 meters? So let's see what happens here. We're not going to solve it. Who cares about the time? They're not asking about the time. They're just saying, can the ball reach 12 meters in height? So I'm just going to look at the discriminant. I'm not going to solve it. So it is in standard form. If I set it equal to 0, fine. B is 14. A is negative 4.9. And C, I'm sorry, yeah, A is negative 4.9 and C is 2. So what is 14 squared? What's 14 times 14?
196.
And a negative times a negative is a positive, right? Is that right? Did I write this down right? Plus. Is this right? Plus 2. No, this isn't right. Start over. All right, let's go a little bit slower. It was modeled by h of t is equal to negative 4.9 t squared plus 14t plus 2. And they want to know if the ball reaches a height of 12 meters. So don't we have to put 12 in here to see if it works or not? Yes. So we're going to leave this alone. And we're going to set it equal to 0 to get our ABC right. So when you subtract 12, it goes away. When you subtract 12, you get negative 10. So your A is negative 4.9, your B is 14, and your C is negative 10, and we're just going to look at the discriminant. So like I said before, if the discriminant gives a solution, it means that the ball can reach 12 meters, right? So B is 14, A is negative 4.9, and C is negative 10. So what did you tell me this was? What did you say this was? 14 squared?
14 squared is 196.
And then a negative times a negative times a negative is a negative 196 on the calculator. And so we get a discriminant that's 0, which means that there's one real solution. So what were they asking? They were saying, can this happen? I shouldn't have circled that. So here's what we're going to write. We're going to say, because because the discriminant is 0, there is one real solution. Therefore, the ball does reach a height of 12 meters. So we didn't solve it. We just took this function and they were asking about the height of 12 meters. And we looked at the discriminant and the discriminant was 0. So because the discriminant is 0, there's one real solution. So because this problem emulated or modeled the real life problem, this function modeled the real life problem when I put in the 12, that means the ball does reach a height of 12 meters, and we didn't have to find the solutions. We didn't have to find, we didn't have to solve for t. Now I think I have time for one more problem. So let's look at another one. So basically we're using the discriminant to cheat and not do the problem, because we're just looking at the nature of the roots to see if it's possible or not to do something. Okay, this problem is on page 143b. Let me read it. So it says a person wants to create a vegetable garden and keep the rabbits out by enclosing it with 100 feet of fencing. The area of the garden is given by this formula. The area in terms of width is equal to W times 50 minus W, where W is the width in feet of the garden. Can the garden have an area of 700 feet? Is that possible? Well, I don't know. Let's put 700 in for area and look at the discriminant. So we got to multiply this out and set it equal to 0. So this would be 50W minus W squared. I don't like negative leading coefficients, so I'm going to move these guys to the left. So I'm going to add W squared to both sides. I'm going to subtract 50W from both sides, plus 700 equals 0. So did you follow that? I subtracted 50 from both sides. I added W squared to both sides. So now I have A being 1, B is negative 50, and C is 700. So we're going to look at the discriminant, and we're going to say negative 50 quantity squared minus 4 times 1 times 700. What's negative 50 quantity squared?
2,500.
2,500 minus 2,800. So isn't this a negative 300? What does that tell you? What does that tell you about this? Huh?
No solution.
No real solution. There's actually 2 imaginary solutions, but there's no real solution. So guess what? This isn't going to work. So because the discriminant is negative, the equation has no real solutions, and in this book they're calling it non-real. So you can say that it has two non-real solutions or no real solutions. Therefore, the garden can't have an area of 700 square feet. It's not possible. So it's not possible. So by looking at the discriminant, we didn't solve the problem. So we didn't use one of the quadratic solving methods. We didn't solve by factoring. We didn't solve by square roots. We didn't solve by completing the square. We didn't solve by the quadratic formula. We used the discriminant to say, that's not possible in real life. So no, can't do it. The problem you made up doesn't work.
Ms. Birch, I have a question.
Yeah.
How come you brought over the negative 50, the positive 50W and the negative W squared instead of just bringing over the 700?
Okay, I don't like the square term to be negative. So I could have multiplied everything through by a negative, but I decided to add W squared so that this would be a positive 1. So
Okay.
you can do it however you want. You can do it however you want, but I don't like, you could have multiplied everything through by a negative 1 to make it positive, but the leading coefficient, if you want your life to be easy, make sure your leading coefficient is positive when you're solving an equation or when you're doing the quadratic formula or the discriminant. You want the leading coefficient to be positive. So on this right here, if you had multiplied by a negative, you would have had negative 700 equals a negative 50W plus W squared. And then you would have added 700 to both sides. So it would have been W squared minus 50W plus 700. So see how it's the same? So however you want to do it, it doesn't matter, but you want to work with W squared minus 50W plus 700. So you could have left it over there, or you could have put it on the left. It doesn't matter. All right, anyhow, that's the lesson for today. Class is over in 1 minute. So I hope you guys have a great day. Okay? Have a good day, and I will see you, on Friday?
Thank you. Have a good day.
Yeah, you're welcome. Pay attention to the deadlines. Don't forget about the exam on Friday morning.
Ms. Birch, I'm still retaking the exam from yesterday today, right?
Don't ask me personal things right now. Let me get out of class first.
Oh, okay.
Then you can feel free to ask me whatever you want.
I'll just message you on Remind then.
Yeah, that's fine. Okay, anybody have any questions about this stuff? All right, you guys have a good day.
Have a good day, Miss Birch.
Thank you. You guys have a good day too. Okay, bye guys. Have a good day.